Imagine standing in the midst of the infinite expanse of the universe, where time does not pass in days or years, but in billions of shimmering light years. About 5 billion years from today, our familiar solar system will no longer consist of planets quietly orbiting a warm sun. Instead, such a view would reveal a sight that tightens your heart with the fragility of everything we consider eternal. The planet you see on the screen is shattered, crumbling slowly but inevitably, like an ancient stone statue eroded by desert winds over centuries. Flames are erupting from the planet itself, streams of scorching lava splattering outward, illuminating the cosmic darkness with a brilliant orange-red glow that makes you feel the heat spreading even from millions of miles away. Rocks are melting because of it, dripping like candle wax under a scorching fire, creating imagined sounds in your mind, the crackling pops of breaking stone, the hissing of a torn atmosphere, blending with the deadly silence of space. The sun has come so close to its star that the boundary between the planet and its host star blurs, like a deadly embrace where heat and gravity clasp each other tightly, refusing to let go. Mercury and Venus in this scenario swell endlessly, ballooning like overinflated balloons heated beyond their limits, their outer crusts cracking and peeling away to expose molten cores inside, where liquid metals churn like rivers of magma on a hellish world. The planet that has departed now that you see here is our own Earth. The same Earth we inhabit today, a vibrant blue planet with oceans sparkling under the morning sun, forests whispering in the wind, and the laughter of children echoing on bustling streets. But in that distant future, no one remains there, not a single human figure or creature left to witness it. Viewed from another solar system, as we are viewing it today, these planets would appear as ghostly apparitions, floating ruins in the void, seen by no one else but scientists hundreds of light years away, through massive telescopes quietly recording their tragic tale. A part of the solar system and the mouth of death. That is precisely what we are witnessing. A reminder that the universe is not a place for eternity, but an unending flow of birth and destruction, where every planet has its own day to face the darkness. In today's video, we will delve deeper into these dying planets counting their final breaths. Some fading slowly like autumn leaves falling in a cosmic season, and others ending swiftly, like a candle snuffed out in a storm. If someone is about to die, then let it end quickly. That is the harsh law the universe imposes. Unrelenting, merciless, simply the cold truth of physics and gravity. To give in to the vast universe of ours, where countless wonders are hidden. Some wonders like these surpass our understanding today. We are merely children gazing up at the night sky, hearts filled with awe mixed with a vague fear of what is happening out there. We are just that, small and curious, trying to piece together fragments from distant light to comprehend endings. A planet advancing toward mystery. It is gradually losing its existence, layer by layer, dust particle by dust particle, like a living body wasting away under the weight of unbearable time and heat. The story of a collapsing planet brings us the fragility of the universe and its infinite power, reminding us that cosmic power is not in planets or anything we can touch, but in the invisible forces that grip everything, from giant stars to tiny dust grains. What is this about you and us? The story is ours, because every disintegrating planet is a mirror reflecting back our own fragile existence on this Earth. The story belongs to K2-22b, a planet slowly dissolving as it orbits its star, a process that has been occurring but is not unique. It has many siblings facing the cruelty of their stars. Planets fading sluggishly under scorching heat and relentless tidal forces. These tales of collapsing planets tell us about the uncertainty and infinity of the universe, evoking possibilities we have never dreamed of. Let these planets embark on a journey and know how they fight in the battle for survival, reflecting on our own existence, forcing us to consider the past of these planets and realize that this one is our future. These scientists, with their arduous work and discoveries, show us how the universe ends, posing new questions and challenges for us, presenting new mysteries that keep us awake at night. lying staring at the ceiling and wondering if we are on a similar path. Imagine a planet on the brink of its own death, standing as a planet being slowly but ultimately destroyed. A planet exhaling its last breath and gradually becoming dust in the universe. The same dust dispersing by making that planet. It has become a star, not science fiction but our sky. The Milky Way holds a truth for us, an endless flow of rebirth from ashes. The mystery remains that K2-22b is one such thing. An exoplanet burning to ash. K2-22b was discovered in 2015 during NASA's K2 mission. A mission that opened doors to thousands of distant worlds. Located about 800 light-years from our Earth, a distance that makes you feel insignificant. As if a mere blink of the universe's eye has brought us here. It orbits its star K2-22. But it is not an ordinary planet. Not one with a final clock ticking down. K2-22b comes so close to its star that the surface, made of rocks and metals, is in constant motion. Temperatures so extreme that surface rocks here melt. The surface of this planet changing in a beehive's care but far from gentle movement. Anything that could even exist here cannot. It is like a furnace, a burning monster, a demon that has set itself ablaze in its own flames. Meaning this planet has now become Basmasa, a creature from Indian mythology that incinerates itself. An image that makes you shiver thinking of the scorching heat burning flesh. Though it is only stone and metal. Has this planet ever supported life? Was there ever any civilization here? Intelligent beings gazing at the night sky with hope. Building glittering cities under a fragile atmosphere. And now turned to dust. Or was it just a corpse moving too close to its star and losing everything? The completion in ashes at K2-22b also makes us think. But the universe makes us ponder its vastness, mystery, diversity, and how many similar things are born across the entire cosmos. And the law of death applies whether it is a planet, stars, moons, animals, trees, even if it is a tree. And this is the truth. The truth that sometimes we must face. And our Earth must do the same. The orbital cycle of K2-22b around its star takes 9 hours and 14 minutes. Completing a full revolution at an unimaginable speed. So fast that day and night blend into a chaotic whirl, where the star's light never truly fades. Only brief shadows interspersed with scorching heat. But such a terrifying orbit results in its outer atmosphere gradually dispersing as dust over this long span. The planet like a cloud slowly breaking into pieces. This planet now has become an ambiguous identity, no longer a unified body but fragments drifting apart. Scientists first detected K2-22b when they noticed its star sometimes suddenly brightens, occasionally flaring brilliantly, a light variation phenomenon that made astronomers on Earth, sitting in dark observatories on lofty mountain peaks, rub their eyes and double-check data, hearts pounding with excitement mixed with doubt. This is evidence of a massive dust cloud around this planet, a continuously expanding haze, a dusty ring encircling the star like a smoky belt from a cosmic forest fire. But now the question arises, how many days will this planet last until K2-22b is continuously losing mass? Estimates suggest that in the next 21 million years it will be completely destroyed. And around its star it will become a dust cloud. Imagine one day this planet is there and then suddenly it vanishes. Only its dust remains, the same dust that will be scattered in the universe by collecting this planet. Now it has formed another planet, a ruthless cycle of rebirth, where the death of one world nourishes the birth of others, making you wonder if our ashes will one day become the foundation for a new star. And then, updates from the latest observations in early 2025. The magnificent James Webb Space Telescope, with its enormous mirrors reflecting light from the farthest corners of the universe, has for the first time given us a truly detailed view of K2-22b. Not a Neptune-sized planet as some initial models suggested, but a disintegrating rocky world covered in thick layers of dust and gas, where periodic dust clouds are emitted in a chaotic dynamical process, creating variations in its transits, moments when the planet eclipses its star. Light flickering like a weakening heartbeat. The James Webb Space Telescope, with its mid-infrared wavelength observation capabilities, has revealed the scorching rocky interiors within, rocks melted and spewing out like the entrails of a torn creature. A sight that left scientists like Nick Tassi and Jason Wright from Pennsylvania State University in awe, spending months analyzing data in laboratories filled with flashing screens. A surge of excitement as they realize this planet is too small for direct detection. But its dust clouds tell the story of ongoing collapse. These observations, presented at the American Astronomical Society meeting in January 2025, show K2-22b emitting dust irregularly, like the coughs of a dying patient. And this opens doors to better understanding how ultra-short period rocky planets, those orbiting their stars in just hours, can exist and disintegrate under extreme heat, where surface temperatures exceed 2000 degrees Kelvin, enough to melt anything we know about rocks on Earth. To expand on this, recent studies using the James Webb Space Telescope's mid-infrared instruments have detected signatures of silicates and iron oxides in the dust, indicating that the planet's mantle is being vaporized layer by layer, with ejection events occurring every few orbits due to tidal stresses that crack the surface like eggshells under pressure. This process not only alters the planet's shape but also contributes to the star's unusual brightness fluctuations, providing astronomers with a natural laboratory to study planetary evaporation in real time. A phenomenon rare enough that only a handful of such worlds have been observed in detail before 2025. The fastest dying planet, the enigmatic BD+05 4868ab, is only 141 light-years from Earth, closer than K2-22b. Near enough that you might imagine a future spacecraft from our civilization could approach it in a few generations. Though it remains a distant dream, it lies so close to its host star BD+05 4868a that the planet has become fused in extremity with the star, radiation and gravity gradually destroying it, so close that its orbital period is just 30.5 hours. Meaning a year is only 30.5 hours in its extremely short cycle. The planet's cycle in the catalogue of NASA's Transients Exoplanet Survey satellite, according to scientists, loses mass equivalent to our Moon every 10 million years. And one day it will go completely extinct. But how is this planet disintegrating so quickly? Why? The transit of NASA's satellite service planet ESO is called the Transients Exoplanet Survey satellite. That is the test called by this shock for scientists to find information researching this planet when it was found. People discovered there is a massive dust trail behind it. It has a tail about 5.6 million miles, about 9 million kilometers. This is two different dust pieces, long kilometers. The front part of the prism split into many sections made of large grains like desert sand, while the back is very fine, made of particles like flour or you could call cement. It separates dust particles due to different sizes when if the planet passes in front of its star. Its dust blocks the star's light for 1 hour, and its transit signal is 15 hours. Astronomer Mark Hahn from the Massachusetts Institute of Technology and his team discovered that this planet is slowly disintegrating due to radiation from its own star. Scientists are guessing a few things. Next, in 1 million years this planet will completely bang. Pennsylvania will go extinct. Professor Jason Wright from Pennsylvania State University knows that BD+05 4868a flat is a host of it. A special brings learning opportunity right now due to the strong brightness of the wire. Scientists have found this planet in Space Network Dual Telescope, the James Webb Space Telescope from Deeper Plan Research. This try to understand this what factors are present inside the planet and how it belongs to its star decomposed due to heat and gravity. This research not only strange spread virus for scientists. Massachusetts Institute of Technology and Pennsylvania become rare opportunity group researchers from Pennsylvania State University while researching this planet. People say that by studying planets and their compositions analysis can be done. BD+05 4868a flat. This research is linked to website archive IV available on And the latest updates from 2025 make this story even more vivid. Astronomers at the Massachusetts Institute of Technology, led by Mark Hahn, announced the discovery of BD+05 4868A flat in April 2025. Using data from the Transients Exoplanet Survey satellite mission, describing it as a rocky world the size of Mercury, with a mass about 6.2 times that of Earth, but orbiting its bright K-dwarf star every 1.27 days, an orbit so intimate that it is 20 times closer than Mercury to our Sun, where surface temperatures reach 3000 degrees, enough to vaporize any minerals, creating continuous lava flows and comet-like dust bursts. Its enormous dust tail, stretching about 9 million kilometers, is divided into two distinct parts, the front section with large grains like desert sand, forming a dense cloud that occults the star's light for about 1 hour during each transit, and the smoother rear section like fine cement powder, trailing behind like a hazy silk ribbon in the stellar wind, a phenomenon causing transit variations up to 15 hours that make data from the Transients Exoplanet Survey satellite flicker like an erratic heartbeat. Scientists estimate this planet is losing material at a dizzying rate, equivalent to the mass of our Moon every 10 million years, and it could fully disintegrate in just 2 million years, a brief span on the cosmic timescale. Enough to make you feel urgency, as if we are witnessing a tragedy unfolding right before our eyes. Building on this, the dual-tailed structure arises from the differential drag experienced by particles of varying sizes in the star's radiation pressure, with larger grains leading the way and finer ones lagging, a dynamic akin to how comet tails bifurcate but amplified to planetary scales. This discovery, detailed in the astrophysical journal Letters, marks BD+05 4868A flat as only the fourth confirmed disintegrating exoplanet, offering unprecedented insights into mass loss mechanisms that could inform models of hot Jupiter's evolution or even early solar system dynamics. Thanks to the host star's brightness, visual magnitude 10.16, the James Webb Space Telescope is planning deeper observations to analyze the chemical composition inside, searching for elements like iron, silicon, and magnesium being ripped apart by heat and gravity. A study not only strange but opening profound insights into how rocky planets form and perish. Like a gigantic natural laboratory where dust and gas narrate endings. To delve further, preliminary spectral analysis from ground-based telescopes hints at sodium and potassium emissions in the tail, volatile elements boiling off the surface and ionizing in the stellar wind, which could help calibrate simulations of atmospheric escape, processes that mirror, on a smaller scale, the solar wind stripping away Mars' ancient atmosphere billions of years ago, reminding us that planetary death is a universal script written in stellar fury. Additionally, there is a suggestion for scientists of our solar system believing in 5 billion years when our Sun will become a red giant. Then perhaps Earth will end in a similar way. The Sun's expansion will further drive away Earth's atmosphere and oceans with heat. It will end, and finally this seed will burn like this will turn to ash. BD+05 4868A flat gives us this teaches that nothing in the universe is permanent. A giant planet, even if alone, it gradually goes extinct under the influence of the star. This discovery explains to us rare brings opportunity to see planets in the universe journey of life, how and one day of ours planet Earth of ours also will go that way, so we will change future of our planet, or one day we also can be in universe it will lose like dust particles. There is a question that only time can answer, but it is not just a dying planet, it is an astronomical laboratory also explaining it to us, helping life cycle of planets ending. It tells us this when someone if planet comes very close to its star, what happens to him. This planet also tells us say that outside our solar system how many amazing things exist somewhere. Stars and planets are being born somewhere, they are dying. K2-22b as well as our universe reminds us of the infinite possibilities of and makes us feel that in this universe when no existence of planets and big stars, if not then what of ours and you today? Let us pause for a moment to visualize BD+05 4868A flat more clearly. This planet is not just a faint blip in data, but a world screaming in silence, where heat from the K-dwarf star, a small orange dwarf slightly cooler than our Sun, with gentler light but strong enough to scorch, is tearing apart its rocky crust, creating deep fissures where lava erupts like the blood of a gravely wounded creature. You might imagine the sounds, though only in your mind, of stone shattering under gravity, the hiss of atmosphere igniting, and the acrid scent of melting metal spreading in the endless void, where no one is there to smell it. Researchers from the Massachusetts Institute of Technology, in their paper on Archive and the Astrophysical Journal Letters in April 2025, describe how its dust tail is not random debris but evidence of rapid decomposition, with the large grain front creating thick clouds occulting the star, and the fine rear extending like a winding dust river, a beautiful yet tragic sight that leaves scientists in awe and sorrow, as it echoes the comets we know in our solar system but on a planetary scale. Expanding this imagery, the planet's dayside likely glows with a perpetual twilight of molten silicates, rivers of lava carving canyons that vent gas plumes detectable as asymmetric transit dips, while the nightside cools just enough for minerals to recrystallize before tidal locking reheats them, a relentless cycle accelerating its demise. Observed through the Transient's Exoplanet Survey satellite's precise photometry that captured over 100 transits in under 2 years, revealing seasonal variations tied to the star's activity cycles. Returning to K2-22b, the James Webb Space Telescope observations from January 2025 have transformed our view of it, no longer a vague Neptune-like world, but an ultra-short-period rocky planet emitting dust in chaotic cycles, with dust clouds altering its transit shape from a few percent to over 1% of the star's brightness, a variation that scientists like Thomas Beatty and Stephen Desch spent hours discussing in meetings, feeling like decoding a shredded ancient book. Further details from these mid-infrared spectra reveal emission lines of calcium and aluminum, suggesting the planet's core mantle boundary is exposed, with vapor plumes rich in these refractories indicating incomplete melting and selective evaporation, processes that challenge existing evaporation models and suggest K2-22b may have migrated inward from a cooler orbit, only to meet its fiery end. A migration story pieced together from radial velocity follow-ups using the Habitable Zone Planet Finder at Pennsylvania State University. And on a grander scale, these stories of K2-22b and BD+05 4868a flat remind us that the universe is a place of fragile balance, where birth and death occur simultaneously, somewhere. New stars are forming from vast gas clouds, devouring dust from lost planets. Elsewhere, civilizations might be looking up and wondering about us. Scientists, from laboratories at the Massachusetts Institute of Technology to observatories in Chile, work tirelessly, using the Transient's Exoplanet Survey satellite and the James Webb Space Telescope to paint the full picture. And each new finding, like the 2025 updates on the dual dust tail of BD+05 4868a flat or the rocky guts of K2-22b, is a puzzle piece helping us understand planetary life cycles, how gravity and radiation shape their fates, and ultimately, ourselves. That is all in today's video, the mysteries of the universe, a greeting from the stars, reminding us to cherish this planet. For, in the vast cosmos, every moment is as precious as a shimmering dust grain before it fades.